The wait is over. This episode of Tech Shop is brought to you by Total Tech Resource Corporation. TTR offers IT solutions, hosted infrastructure, and solutions development. Visit TotalTechResource.com. TTR, we are IT. Welcome to episode 7 of Tech Shop. I, of course, am Paul Bauer, aka Twitter.com/EldoPablo. I realize it's been a few months since the last episode. I've made some changes in my life that have kept me pretty busy. I started a new job at a small company in La Jolla, California, where I manage the IT department. It takes up a lot of my time. One of my recent tasks was setting up a homegrown iSCSI SAN. Since I've done a lot of work on that lately, that's what this show is going to be about. In this episode, I'm going to give you several free software options to build your own iSCSI SAN on the cheap. First off, what is a SAN, you're wondering? SAN stands for Storage Area Network. Wikipedia describes a SAN as a dedicated storage network that provides access to consolidated block-level storage. I've been asked several times what the difference is between a SAN and a NAS. NAS stands for Network Attached Storage. The difference is in the protocols used. According to About.com, a NAS is a single storage device that operates on data files, while a SAN is a local network of multiple devices that operate on disk blocks. Think of it this way. If you're using a device as a file server with CFS or NFS shares, that is generally considered a NAS device. If your device connects to your servers over a fiber mesh or a separate dedicated iSCSI network, and they present raw disks to the server, then that is generally considered a SAN device. Got the picture? Now that you're wise to what a SAN is, let's look at 3 open source options for making your own SAN. Now, even though all these options do provide NAS features such as CFS and NFS shares, FTP, and rsync, we are mainly looking at these for their ability to serve up some iSCSI goodness. First one up is very popular. It's called FreeNAS. FreeNAS is based off of FreeBSD Unix and comes with a very easy to use web interface, thin provisioning, dedupe with ZFS, snapshots, and offsite replication. FreeNAS is great for a simple solution, but I've yet to find a tutorial on how to set it up in a cluster for high availability. That brings us to another big name in open source storage, Openfiler. Openfiler is based on RPath Linux and has a unified SAN and NAS protocol suite. Can be used as an iSCSI or fiber channel target, and it has a convenient web-based administration and allows for block-level replication. Openfiler does not have any thin provisioning or dedupe capabilities. One feature that Openfiler claims to have is the ability to cluster Openfiler for high availability. While this is true, I found it to be very flaky and unreliable with large amounts of storage. Openfiler can be clustered with CoroSync, and the LUNs can be replicated using DRBD. When I tried clustering with DRBD, I found my SAN to be completely unusable in VMware, and I/O weight was pretty consistent at 30 to 40%. That brings us to our final option, iSCSI Enterprise Target, or IET. IET is a software package that you can run on your favorite Linux distro. I first heard of IET from the owner of Total Tech Resource Corp in San Diego, who is also this episode's sponsor. TTR is running IET on Gen 2 Linux, and they say it works flawlessly. I decided to try it out by myself, but on Ubuntu. Not only that, but I decided to one-up them and cluster IET on 2 nodes for high availability. I didn't want to do that with DRBD either. I figured out a better way using GlusterFS. GlusterFS is a distributed scale-out NAS file system developed by Gluster. It works at the file level, so there is no metadata that needs to sync, as with DRBD, which dramatically improves performance. With GlusterFS as my network RAID mechanism, and IET as my iSCSI software, I just needed something to manage failover. That's where Heartbeat comes in. With Heartbeat, I can have a virtual IP address that is shared with both nodes, but is only active on one node at a time. Servers write data to the active node, which is going through GlusterFS, and simultaneously written on both nodes in the cluster. If one node fails, Heartbeat can detect it and swing the virtual IP address over to the other node in the cluster. Since the second node already has a copy of the data, iSCSI operations don't skip a beat. Did I mention that the GlusterFS/Ubuntu solution provides dedupe and thin provisioning too? It provides dedupe if you stretch GlusterFS over ZFS, which you can easily install on Ubuntu Linux. Just make sure that your server has plenty of RAM for dedupe operations. Thin provisioning is accomplished by creating sparse files using the dd command. If you want to see the full instructions to build your own Ubuntu SAN cluster using GlusterFS, check out the link below. There you have it, 3 free options for creating your own iSCSI SAN solution. If you buy the right hardware, your homegrown solution can save you a ton of cash compared to a commercial solution like NetApp or EMC. This concludes this episode of Tech Shop. If you have any questions, hit me up in the comments or shoot an email to me at info@techshop.com. Also, if you aren't already, please follow me on Twitter and on my blog at bowerpower.net. Check back next time for your prescribed dose of Tech Shop. I realize it's been According to About.com, a NAS is a single storage device that operates on data files, while a SAN is a local network. From the top.